As I promised to the 9 o'clock and the 10:25 classes, first of all, I enjoyed having you, and I hope you got something out of the lesson. So I'm going to go over what amounted to 7 problems. I'm going to go through them again step by step. No one had any questions about any particular problems just yet, so I'm just going to go through the whole lecture. Once I have recorded it, I'm then going to load it to YouTube, send you the link, and so you will have something that you can review between now and next Saturday. So let's get started. So we're going to go through substitution. We have x is equal to 4, y is equal to minus 4, and we have the equation x minus y. So we have everything that we need to solve this equation. So we have 4 for x, we have minus 4 for y. So then our solution to the first one is D. So you're given the equation of 2x plus 7 is equal to 13, then 3x plus 1 is what you want as an answer. So we're going to use the first equation. We're going to get 2x by itself by subtracting 7 from both sides of the equation. X is going to be equal to 6. We're going to get x by itself by dividing both sides of the equation by 2. And then we have the answer, x is equal to 3. And your option is A. This doesn't look like a substitution equation, but you're given all the information that you need to solve it. You're given that if A plus B is equal to 3, then 6 minus A plus 2 minus B equals something, one of these options, which you can see that I've already checked what you're going to do. I've already circled the option is C, but now I'm going to go through the steps. What I did here was I was checking through what are my like terms. So my like terms are the 6 and the 2 because they're numbers. My like terms here are the A and the B, but they're minus A and minus B. And that's equal to something. We know 6 plus 2 is 8. We take the negative from in front of the A and the B, and now we have A plus B. But A plus B is a known quantity. It's given as 3. So then 8 minus 3 equals 5. And again, that's going to be our option C. So we're given choices. If R and S are positive integers, how many integers are greater than the product of R times S and less than the product of R times S plus 1? This is a classic test strategy within the SAT. So let's make things easy for ourselves. Let's say R is equal to 3. S is equal to 4. So now the product of RS is going to be 3 times 4, which is going to be 12. The product of R times S plus 1 is going to be 3 times 4 plus 1, or 3 times 5, which is 15. Now, what number is greater than the product of RS, which is 12? Well, that number is 13. And what number is less than the product of R times S plus 1, which of course we know is 15? That number is 14. So what we're looking for is, once we solve these equations in A, B, C, and D, they have to total two integers, one which is greater than the product of RS and one which is less than the product of R times S plus 1. So A is R plus 1, which is, our R is 3 plus 1, which is equal to 4. B, R minus 1 is equal to 3 minus 1, which is equal to 2. And C, S plus 1 is equal to 4 plus 1 is equal to 5. And D is S minus 1, which is equal to 4 minus 1 is equal to 3. So again, it says if R and S are positive integers, how many integers are greater than the product of R times S and less than the product of R times S plus 1? Well, we said, based upon the fact that 13 satisfies that here and 14 satisfies that here, then how many integers? We said was 2. Well, this is 2. B would be your answer. And that's how you have to think about it. It's kind of a logic problem as well as an algebra problem. If A plus B equals C, which of the following is A squared plus B squared? And as I said in both lectures, the reflexive thing to do will be to go for this C squared because it looks like the Pythagorean theorem. However, we're going to do the same thing that we did in the previous problem. We're going to make life easy for ourselves. Previous problem was R and S. This one's going to be A. So I'm going to pick my A to be 2. I'm going to pick my B to be 3. So A plus B is equal to C. So now we say A plus B is equal to 2 plus 3, which is equal to 5. Now we know that we have a value for C. C is 5. Now all we do is just plug them in and see which one works. C plus 2AB is equal to 5 plus 2 times 2 times 3, which is equal to 5 plus 12 equals 17. B, we know what C is. C squared is equal to 5 squared, which is equal to 25. C C squared minus AB is equal to 25 minus 6, which is 19. So all I'm doing is plugging in my values. And then D, this is going to be C squared minus 2AB, which is going to be 25 minus, we did this earlier, 12. And that's going to be 13. Okay. So what is A squared plus B squared? Well, A squared plus B squared is equal to 2 squared plus 3 squared, which is equal to 4 plus 9, which is equal to 13. So your answer is D. But again, you might have reflexively chosen B because it looks like the Pythagorean theorem. Again, that is a trick that they do on the SAT. So this was our distribution. What we decided is these are two quadratic equations. The first thing we're going to do is we're going to take that -3, and we'll let the camera focus. There you go. I'm going to take the -3, and we're going to distribute it into this quadratic equation. So I'll drop down here 4x squared plus 3x minus 7 minus 3x squared plus 12x, because negative times negative is a positive, and then minus 21. Now, here's where we do the combination. 4x squared minus 3x squared. That should be a negative. I tend to do that when I go fast. Minus 3x plus 12x and then minus 7 minus 21. So we will come out with x squared plus 9x minus 21 as the answer. Universally, I got the answer that no one liked word problems. This helpful guide is from the Princeton Review. This particular SAT prep edition is on page 271. So they take this basic approach. Read the final question. Read and underline the actual question that is being asked. Second point is let the answers help. Look for clues on how to approach the question and opportunities to use processes of elimination, or POE. And then the third one is work using bite-sized pieces. Start with the most straightforward piece of information. And here is the word problem. An online store receives customer satisfaction ratings between 0 to 100 inclusive. In the first 10 ratings the store received, the average arithmetic mean of the rating is 75. What is the least value the store can receive for the 11th rating, still be able to have an average of at least 85 for the first 20 ratings? Okay. Now, there's a couple of things I want you to notice here. You can go back in the video and you can review what Princeton said, but one of the things they said was underlined. So I underlined or double underlined some insightful things. 0 to 100 inclusive, which means that the ratings will include either a 0 all the way up to a perfect score. And then I double underlined the first 10 ratings, and that the arithmetic mean of that rating is 75. And then what they're looking for is the least value for the 11th rating. And that's kind of where I want to key you in on how to look at this. And then the average of at least an 85 for the first 20 ratings. So what I like to do with word problems, and every single problem that I've encountered as an engineer is essentially a word problem or a question that the customer had. I like to break it into two things: a given and then my other column to determine. You're going to hear my pencil sharpening. So look at what I've underlined up here. You got ratings, of 0 to 100. And then you got an arithmetic mean, that's what this X bar means, of 75 for the first 10. And then you got an arithmetic mean of 85 for the first 20. And what do you want to find? That's what to determine means. You want the least value of the 11th rating and still have an arithmetic mean of 85 for the first 20 ratings. I think I have enough room just to get it in. So for your first 20 ratings, you got a total of 20 times the arithmetic mean of 85. And that's going to be equal to 1,700. And then you've got your first 10 ratings. That's going to be 10 times an arithmetic mean of 75. And that's going to give you 750. So if you take the first 20, and now you're going to subtract it from the first, subtract from it, excuse me, the first 10. So that is going to give you 950. And what does 950 represent? Well, it represents ratings (11 through 20). Now, the ratings, going back to our word problem, are 0 to 100 inclusive. So I am going to assume that for ratings so here's rating number 11 and ratings 12 through 20. So I'm going to assume the maximum for ratings 12 through 20. And the maximum would be they each got 100%. Well, ratings 12 through 20 would be 9 times 100, which would be 900. Now, what did we say? We wanted to, what is the least value the store can receive for the 11th rating and still be able to have an average of at least 85 for the first 20 ratings? So the least value out of a total of 950 would be 950 minus 900 would be equal to 50. And that is how you would do that word problem. So look at it a couple of times. You can email me. My email is rlgoodwin@aggies.ncat.edu. And if I see it, you have a question, we can jump back on Zoom and we can work through it again. Thank you and have a blessed day.